Greetings, everyone. My name is Lelokole Pata. I'm currently a student at CUT, the Central University of Technology, based in the Free State Province of South Africa. Here with me, I have my student card. Just as a disclaimer that truly this is my own work. Okay, today I'll be presenting my project that I've designed through engineering methods, skills, and tools, including information about technology that is available to us. Now, the title of my project is an automatic temperature and humidity management system that I've designed for a newspaper production business. I've created a poster just to give you a clear insight and walk you through the process of designing this project. Here we go. Now, this business is facing significant production challenges due to poor paper quality, primarily caused by environmental factors like humidity and temperature. Now, these conditions can lead to issues such as paper jams, misfeeds, and affecting the overall efficiency of the printing process. Now, to address these issues through the application of scientific and engineering knowledge to solving real life problems that we can encounter, such as in this case, the automated system I developed is to monitor and control the storage area conditions for proper preservation of paper quality. My primary objectives were to maintain optimal storage conditions for paper, which specifically temperatures between 20 to 25 degrees Celsius and humidity levels between 35 and 55%. And I had to create a system that will automatically monitor and respond to fluctuations in these environmental parameters. Now, knowing our objectives, we can proceed to methods and materials. And under methods, when designing the system, we know that our system must be capable of measuring the temperature and humidity. That's how we were able to locate and utilize a DHT11 sensor for real-time monitoring. And for processing data, we'll be using our Arduino Uno microcontroller to process the data from the DHT11 sensor. And the Arduino Uno microcontroller will be playing a very vital role in the control mechanism, whereby it will be controlling the humidity and temperature. And if the humidity is below 35%, it activates the moist sprinkler. And if the humidity is above 55%, we activate the fan to dehumidify the control room. Now, if the temperature is below 20 degrees, we activate the heater. And if the temperature is above 25 degrees, it activates the fan for cooling the storage area. And we also included an LCD display for real-time temperature and humidity readings for easy monitoring of the user. We proceed to materials. Here is all the materials we're going to need to complete this integrated system. We have our DHT sensor for measuring temperature and humidity, our Arduino Uno microcontroller that processes the data and controls the relays, breadboard for assembling the circuit, wires for electrical connections, and our LCD displays the sensor data. Here is our relay modules, manages control of the devices, and our 5 volts power to power the system. LEDs to indicate system status, resistors to manage current flow in the circuit. Now you can see here are all the pictures of how these materials look in real life. We have our DHT sensor, our Arduino Uno, our breadboard, our wires, our LCD display, our 4-channel relay module, our battery, our LEDs, and our resistors. Moving forward to the block diagram, and this is how we know that our system is going to work or look like, and how it's supposed to work. Now, here we have our Arduino Uno microcontroller, powered by a 5-volt DC supply and DHT sensor, as you can see, powered by a 3.3 DC power supply, I2C 5 volts, our relay modules, and all the control mechanisms, the humidity fan, sprinkler, moist sprinkler, temperature fan, and our heater. And the relay module is supplied here. Moving forward to our schematic, here's our schematic, and how showing us how the connections of the system are going to be. You can see our Arduino Uno, our LCD, and DHT with our relay module. Now we will be going to use LEDs as indicators that the system status, instead of using the actual heater, fan, and sprinkler. We are going to use LEDs just to show that that system is working as needed. And all these are the wires that show our connection. We have our flow chart. This is the concrete. We can say it's a concrete foundation for our software part. This is whereby we telling the microcontroller what to do and the system design in this system and how it should operate. Here you can see this is an integrated circuit. Now I'll be showing you how the integrated circuit works. I'll be simulating the parameters so that it can respond to the parameters that will be simulating. Let's proceed. Here is our integrated circuit. You can see here is our LCD, our DHT sensor, and our LEDs to indicate when the system is activated. A will be representing the humidity fan, which will kick in when the humidity is above 55. And B is our humidifier, which is the moist sprinkler, and it would kick in if the humidity is below 35. And here is on C is our heater, our temperature heater. If the temperature is below 20 degrees, our LED will come on. And D is our temperature fan. It will kick in if the temperature is above 25 degrees Celsius. And as you can see already in this room where I'm simulating this, the temperature is already above 25 degrees Celsius and the fan is on. Now, inside here, let's take a look on the inside. We have our Arduino Uno. We have our relay modules, our breadboard, wires, and here is our resistors. And here we are supplying the system from PC. We can preferably, you can use a 5-volt DC, but cable still works. Now, we will be decreasing the temperature. I will be using some ice to decrease the temperature, and also it has the ability to decrease the humidity. So we can begin placing the ice along the DHT sensor. The temperature fan came off because the temperature is now on the right parameters, so no need for any influence. But the humidity is below 35. Now the blue LED B is on, representing that the moist sprinkler is trying to restore humidity. Okay, let's see. The temperature is at 20 now. 20 degrees Celsius, below 20. Now that our temperature is below 20, at 19, our heater is on. Our heater fan is on, trying to heat up the room so that the temperature can be above. Now we're going to use a lighter to increase the temperature and also to increase the humidity, but the humidity side, nothing is on currently because the humidity is, there we go, the humidity just became above 55, running at 60, 64. Now the fan is kicked in, trying to restore the humidity to be below. Okay, let's increase the temperature and see if the temperature fan will kick in. Let's try to put the temperature above 25. You can see the temperature increasing, 24, 25. There we go, 27 degrees. Now the fan has kicked in. Now that's how the integrated circuit was successful. And this automated system will offer several benefits: improve preservation of paper quality, leading to fewer production issues, increased efficiency in printing process, also real-time monitoring, allowing for proactive management of storage conditions. So in conclusion, we can say that our automated temperature and humidity management system for this newspaper production company not only addresses the current production challenges, but also sets a stage for future enhancements as technology evolves. Thank you for your attention and your time. I'm happy to answer any questions you have. Thank you.